There you go, so the lunch didn't kill you. Good afternoon, everybody. Welcome to the Impact of Cloning and Virtualization on Active Directory Domain Services session. That's the longest title ever. I think I may actually win the award for that this year. My name is Dean Wells. I'm a program manager with the Active Directory product group. We've delivered this session numerous times now. We delivered it to a very, very large crowd at TechEd Europe, so if you were there, why are you here again? Clearly you didn't listen. Same content. We've enhanced it a little bit, but nothing major has changed bar one fact. We did learn something in the meantime, and I shall make every effort to point that out, assuming that I actually managed to get to that content. Last time around, the session was extremely interactive. That would be one of my goals this time, but it's a large room again, so people are a little bit shy, so you're more than welcome to come and pose your question at the end if you prefer. Either way around, assuming we do get to that, I shall point out the slight difference between what we knew then and what we know now. It's only one very, very minor thing, but it's to do with time. So, without further ado, let me kick straight into this. I will mention before I start, as you may have noticed, I've got a bit of a cough at the moment, so if I turn the mic off and cough, please excuse me. It's going to happen a couple of times, I think. Let's take a look at the objectives then. So what I want to do is try and focus this not on the logistical aspects and some of the concerns that we've got surrounding admin role separation, but try and focus the content onto the technical challenges that you as AD administrators or hypervisor administrators face when placing domain controllers and/or Windows in general on virtualized platforms. It's not so much the platform itself, but it's the capabilities that they bring and the ease with which they bring them. Specifically, and per the title, cloning. Cloning is actually quite cumbersome to do on physical machinery. For those of you that have been around a while, we used to use technologies such as Ghost, and you could mirror a disk, or you'd use RAID technologies, or just regular mirroring, or any kind of cloning software. But it was really quite painful to do it. In virtual machinery, would you all agree it's ridiculously trivial to clone a machine? You copy a file, you give it to another VM, and you power it on, and now you've got two of them, and they are bit for bit identical, with the slight nuances defined in the VM definitions file, depending on whose hypervisor it is. So that's really what I'm trying to focus on here, not this admin role separation concern that we've got regarding AD admins, hypervisor admins, and SAN admins. Those are still, for the moment, somewhat intractable problems. We haven't yet found good solutions for them, so basically it comes down to process and still does. So I want to basically emphasize some of the Windows assumptions that give rise to these problems when you put a domain controller inside a virtual machine. There are a number of elements that Windows has within its architecture, and then very specifically that AD builds on top of, and then introduces its own complexities, that are unique machine identities or domain identities. Some of them are, for example, part of our replication fabric. By a quick show of hands, how many of you know what an invocation ID is? I would say that was about 3. My guess is they had blue shirts, and I can't see them, but that's probably not far off the mark. The invocation ID I'll discuss in a second, but that's but one example of something that absolutely must be unique to every single domain controller. If you clone machines, they can appear to operate just fine, and you may think that the only thing you've done is broken that individual instance of a domain controller. But in actual fact, what you've done is you've introduced what I like to term distributed poison. You didn't just poison those two machines because they had a name and IP address conflict. You actually introduced distributed poison into the directory from which recovery is unbelievably difficult because you've basically invalidated a fundamental assumption in our system. So those are the kind of goals that we're looking to cover in this so that you can walk away with this room with enough of a technical grasp of how Windows and AD functions to understand what you should and should not do in these virtualized environments. I can try and cover every single scenario, but as you've probably already realized, for those of you that work with VMware ESX, for those of you that work with Hyper-V or Citrix, there are many, many capabilities that these guys bring to bear that are completely radical relative to physical machinery, and I can't possibly cover them all. So, moving straight into it, let's start off with some basic Windows notions. Machine identity. Let's see which way this goes. I often find, if any of you have done presentations before, they're always backwards. So the left button goes forwards. Let's see. It does. So what I do is turn it upside down. Genius. All right. Computer identity comprises, and we'll take a look at this. Nothing radical here, so let's make sure we shift on nice and quickly. A computer name stored locally and suffixed with $. That's just legacy. That's the way that we used to represent it. An IP address. We all know about IP addresses. How many of you are very familiar with IPv4? Quick show of hands. I want at least, that's good enough for me. Good. Moving on then. And SIDS. Who can tell me what SID stands for? Just yell it out. Look at that, in tandem, beautiful. Yeah, security identifier. They've been around in Windows for many, many, many years, going back as far as Windows NT, and in actual fact, they were there in a lesser form in even some of the LAN Manager incarnations that came before that. Who's old enough in this room to remember LAN Manager? Sorry. All right, let's move swiftly on then. What is a SID? Let's give you a decent definition. How many of you have heard of our protocol documentation? Now, all the blue shirts in the room that work for Microsoft, all of us are like, yeah, we have. This is a mass of information. It quite literally describes the Windows system interactions as two copies of Windows or more communicate with one another on the wire to the level by which, if you were a developer, you could literally translate that English language into code and simulate the Active Directory system. So when I say that these are as detailed as it gets, second only to the code itself, that's no exaggeration. You can literally reinvent Active Directory from the content in these documents. In the Microsoft Active Directory repository alone, I think we have somewhere around 60 of them. And they all have certain names. So what I've done here is I've given you a snippet from our protocol documentation, which is freely available online, that defines exactly what a security identifier is and what it's comprised of. So I'm not going to read that out for you because I'm hoping most of you have seen that before. How many of you have seen something that looks like that before? Possibly in an access control list, right, when it didn't resolve to a name, so it comes up with the SID, or when you're doing a whoami/user, or whoami/groups, and then a couple of other switches to dump it all. Okay, basically then, short definition, a SID is the means by which we identify objects within Windows, principals we call them, to which permissions can be assigned. So a user is a principal, a security principal, a group, a computer. We have something called an INET.org person, which is there for standards-based compliance with legacy directory technologies. I call them legacy now because, let's face it, they're not as pervasive as they once were. And we have another one that was recently introduced called a managed service account. Who's heard of a managed service account? Okay, so it's a special type of account that you run services under. So it's a security context. Normally you would configure a user, but the difference being its password is self-managed. So you don't have to worry about resetting its password and then going around and reconfiguring all the machines on which that service runs to know about the new password. A very, very highly asked for feature that we threw in, I think, in Win 7 and 2K8 R2. Managed service accounts. All right, SID assignment then. Machine SIDs. So how is a SID assigned? Well, there's another one of those documents, Microsoft SAMR. That's the Security Accounts Manager documentation. So this will take you through literally everything about how Windows identities on a local machine function, and to some extent, some of the protocol interactions that occur between domain controllers and domain members, or domain controllers to domain controllers. So let me ask you a question. How many individual SIDs does a computer that's serving as a domain member have? So if you've got a computer at home, and it's not a member of an Active Directory domain, how many SIDs does it have? The machine itself. 1. When you join it to an Active Directory domain, does it use that SID as its identity within the domain, or does it get another identity to represent its relationship with the domain? It is the second. So a computer that is domain joined, running the Windows operating system all the way from Windows NT up, actually has two SIDs. The SID that's given to it as its computer account is created in AD, and the SID that was given to it during the generalized phase of either setup or sysprep. The latter of those two, the one that's given to it during setup, is only useful locally. It has very little meaning beyond the confines of the local operating system. So I can't put it over there and ACL it against a resource on another box and expect it to be useful. That identity is scoped only to the local box. However, the SID that was given to the computer account when it joined the Active Directory domain and the computer object was created, I'm sure you've all seen that, that is the identity of the machine on the wire and within the trusted Active Directory environment. Give me some nods if that makes sense. So that is the identity of the machine that you would be permissioning against resources for services that run as, for example, network system. So what about the domain SID? Who can tell me, very open-ended question, when you DC promo a brand new domain, either a new child domain in an existing forest, or you provision a brand new forest, where does the SID of the whole domain come from? Where does the SID of the whole domain come from? Anybody? I think I heard it out there, but it was a little low, so I'll guess that it was right. It comes from the workstation or the server that actually promoted it. So as that server was installed and we ran through that generalized phase, we make up a SID using a very complex randomization algorithm. The SID of that machine is assumed to be unique because the algorithm is assumed to be good enough to do so. So we simply elevate that, and it becomes the SID of the domain. Now, if I go back a slide, if I can hit the right button, you can see here on this, if you take a look at the beginning, the S1-5, the S doesn't really exist. That's a prefix that we throw on there for human beings. The 1.5 is part of versioning and revision data. There's almost nothing else out there. If you've seen anything that's different to S1.5, it's not ringing a bell with me right now. It's possible. Certainly the 1 is going to be consistent all the time. There is no S2. And I believe the 5 is consistent as well. The documentation is on the board for you. What comes after that, highlighted in black, is the piece that represents the individual machine. That's the unique piece. So every domain has a unique one of those. The red piece will be common to all of them. And then the yellow piece is the part within a domain that is unique to every single security principle. Every user, every group, every computer, every MSA, every INET org person, they all have a different, what we call a RID, a relative identifier. Who's heard of the term RID? Okay, so a SID is comprised of some issuing identity metadata, a piece that's specific to the account domain that all domain controllers will share, and then a uniquifying, if I can even use that term, piece at the end. We're in America, so I can abuse the English language, right? That's okay. Sorry, I realize you're all American, but, you know, it is British after all. What is that one that I love the most? Winningest. You can't say that. You can't just shove a suffix on the end of a suffix. Winningestness. What happens if you're no longer the winningest coach? Does that mean you're now the winningestnessless? And do we keep on going? So therefore, if you're doing that, you're the winningestnessless-ing coach. You can't keep going. Anyway, so I'll do it here just for the sake of explanation. We uniquify the account domain SID by throwing a RID on the end. How many RIDs can a single domain have for its entire lifetime? 2 correct answers. Very well done. I'd give you a prize if I'd bothered to bring any, but I didn't, so unlucky. But yes, that's the correct answer. We have 1 billion RIDs within a domain. 1 billion. Is anybody concerned by the limitation of that number? Good. We did some back-of-the-napkin math, and we figured out that you'd have to be creating something like 1,000 accounts every second for about 12 years in order to burn through that. So, based upon that data, do we have any customers out there that have burned through their RID pools? Of course we do. This is Windows. We have everything. Everything you can imagine has probably happened, and we've got a little bit of an increase in the number of instances of those cases of late. We still don't know what the cause is, but it's under active investigation from CSS and from myself and others in the product group, because we can't figure out where they've gone. The correlation between the number of users and groups in the domain is nothing like that. In most cases, they've got no more than 10,000 accounts. How did you burn through 1 billion? They must be doing something that's architecturally against the assumptions the system makes. So I won't spend any more time on that, but it is possible to burn through it. If you do burn through it, what is your way out of hell? Assuming that that situation is labeled as hell. You migrate the domain. So you build a new one and you migrate it all. Not a viable proposition, I'm hoping most of you realize. It's extremely complicated and a very lengthy task. Pain will be felt for months after that as ripple effects, so you need to make sure that you understand this. Who would like to know a command that can tell them how many RIDs are left? Okay, dc-diag /test:/rid-manager/v for verbose. dc-diag/test:/rid-manager/v for verbose. That will tell you how many RIDs are left in your global RID space within the domain. If your domain has been around for a long time, or you've got concerns about the way it was managed before you got there, because obviously you do a great job, then run that command and have a look. Put your mind at rest. Okay, now, in order to try and prove out what happens in virtualized environments, I want to walk you through a few scenarios that tend to manifest on hypervisor platforms much more so than they ever did before these became pervasive. Now, pay close attention here because some of these scenarios are somewhat complicated. So if we start with a domain-joined machine and we name it M1, we clone it and we boot up the clone, i.e. we copy the VHD, that's how we cloned it, and we boot that machine up. It's just a domain member. So I've now got two domain members, both called M1, running simultaneously. Let's assume that I resolved the IP address issue, but that's the only thing that I fixed. So they now have unique IP addresses. In fact, it may have even resolved it itself because it was using DHCP. Can these machines coexist? By show of hands, yes. No. And the rest of you are squarely on the fence. Well done. That was about 4% in total. Maybe there's another answer. Yes, with some conditions. Yes, there you go. That's the right one. I think you got the impression from the intonation in my voice there, didn't you? Yes, with some conditions. Yes, the conditions being the following. It will work for a period of time up to that point where the domain member decides to change its password. How many of you know that computers, have passwords with Active Directory domains? Excellent. For those of you that didn't raise your hand, they do. So what happens is on a 30-day, I think it's 30 days now, it's been 10 days, 14 days, and 30 days. I have no idea where we're at now, so I'm going to put a finger in the window and go, it's 30 days now, but it could be 14 or 10. They all sound equally valid in my head. I'm just getting too old. Every 30 days, I think, the computer changes its password. And it uses this maximum entropy, huge number of just white bytes, just random garbage, and it resets the password. It then stores a copy of that password in the local machine registry, which it obfuscates, which means it scatters the bytes all over the place, and only it knows the mechanism by which it can pull it back together again. And then it obviously sets that password on the computer account object. Now, if we've got two machines using the same name, how do you think computers know which object is theirs? Because the name in the directory matches the name of the machine. So what happens when the first one goes to reset its password? It works. What happens when the second one goes to reset its password? It still works, because it's a reset. It doesn't require knowledge of the prior password. We assume, because you have a secure channel with us, that you are who you say you are. You already proved that by virtue of having authenticated. Subsequently, the second machine wins. The first machine still has a valid session. It's still got all the tickets, the curb tickets. It's got all the tokens. It's got all the authorization data it needs to function until what? Until you reboot it, which of course we never do with Windows. So oh no, that's not right, is it? We do. So it's not going to work for very long at all. You're going to have to reboot that client at some point, a couple of days, maybe weeks even. But at some point or other, one of them is going to die because it loses the synchronization between the password cached in its registry and the password set on what it thinks was its own computer account object. So they will appear to work for a brief period of time. So what about this? What about if we offline unjoin it? By that, I mean, I'm going to tell it you're no longer a member of the domain, but I'm not going to do it in such a way that it can actually tell the domain that it's doing it. So I offline unjoin it. You can actually do that in the regular graphical interface. It will just give up eventually. We then rename it to M2, and we join it back into the domain. What about now? By show of hands, will it work? Gentleman in the front says, with conditions. The conditions at this point, that's true, are much, much less. They're much more quantifiable. This will actually work pretty reasonably. In fact, my guess is if this was a server or a let me take that back. If this was a workstation, it's unlikely, though perfectly reasonable, it's unlikely you would ever encounter a scenario where it would actually break. But these are the conditions I'm talking about. Remember, because we rejoined it as M2, it recreated a new computer account of its own, and it set a password upon it. Go ahead, sir. So the gentleman's statement there, not so much a question, but he's informing me as to where they find problems with it, is in clustering virtualization. So when we virtualize clusters of machines, that would certainly be one of those scenarios, and that's specific to server, obviously, which is why I sort of changed my scenario a bit. It occurred to me as I was going through it, where the SID on the machine might be something, an immutable identifier that the clustering technology leverages for its own purposes. It's outside the scope of Windows, and it's outside the scope of AD, but this is a precise example. Virus vendors, antivirus, I should say, not virus vendors, antivirus vendors do the same thing. They may leverage the SID as an identifier such that when the machine checks in to go and get antivirus definition updates, they version it against the SID. Well, if two machines have the same SID, and the first one goes in and gets its AV definition updates and pulls them down, what happens when the second one calls in and tries to pull them down? The server thinks it's already got them. They have to have some way of uniquely identifying the calling agent, and they can use SIDs. Again, these are all outside the scope of AD. They're all outside the scope of Windows. It's other components using these immutable IDs as something of their own, which we can't predict. However, those scenarios aside, M2, as the scenario is painted on the board, would continue to work just fine. I wouldn't recommend it, because if you were to store a file on that disk and give the local computer access to it, and you then had some third-party file replication engine that replicated the file from M1 over to M2, since M2's local system and local SID are identical to M1, it's instantaneously going to inherit the same permission to the file. The SID is the identity. If the identity is the same, then access to anything is the same. It just depends on whether you can get something that's authorized to access it between the two systems. So we're certainly not recommending this. What is the recommended way of doing this? Sysprep. So could you clone the machine? Yes, but ideally you should run sysprep beforehand and then clone the machine in that halfway house where it's waiting to be booted up, and let sysprep do its generalize. And then the other components where it calls all the sysprep providers and does the other things. If you're not familiar with that, on Windows 7 and Windows Server 2008 R2, this is trivial. It's under the Windows sysprep or Windows System 32 sysprep, I forget which. You run the sysprep.exe binary, and it does it all for you through the UI. It is amazingly trivial. So this does make cloning VHDs for the purpose of deploying new Windows machines, assuming you've got the licensing sorted out, perfectly viable, as long as you do the sysprep before you do the clone. Let me give you a much more complicated scenario, and this is a realistic one. We've now got actual evidence that people do this. So, in step 1, a template VHD file, that one at the top there in yellow, that's used to deploy new Windows servers. How many of you deploy Windows servers using template VHDs, for those of you that have got hypervisors? Okay, regularly. So you know exactly what I'm talking about here. So we deploy this brand new Windows server. That cloned VM, that copy of the template, is renamed to something appropriate, and it's then used to promote the DC that created the domain peach.com. Now you notice the SIDs here. This S-20 and S-20-500, I am vastly simplifying these to try and make it human memorable. Otherwise, it would be these massive numbers, and you'll never be able to differentiate them. So this is an oversimplification of what SIDs really look like for the sake of us. So the assumption here, then, is I didn't sysprep it because I didn't tell you I did. I simply copied it, and then I promoted a domain from it. Therefore, the machine's SID must have been what? The template VHD's SID. What was it? S20, gentleman in the front again. So the template VHD at the top has a SID of S20. Remember I told you earlier, where does the domain SID come from when you create a brand new domain? We copy it from the machine that gives birth to the domain. Well, this is the guy that spawns, that seeds this brand new Peach domain. Subsequently, the domain inherits it. So if you look at the Peach administrator user, the RID of the administrator is always the same. I believe I got that right. It's 500. It's a well-known RID. So we simply suffix it onto the account domain SID, the S-20, resulting in the administrator SID of S-20-500. In reality, it would look more like S-1-5-21-500. But again, simplifying for the sake of comprehension. A child domain is promoted from a clean OS install in a branch office, and we called it Princess. No, I have no idea why. It was funny at some point in time, but I've lost the joke to time now. So I have no idea why I decided to call it Princess. Oh, no, I do. But it's not interesting to you, or not suitable, one of the two. Anyway, so I create a new domain, a child domain of the peach.com forest, using DC promo for a clean OS install. And I call that domain Princess. And you can see there that that domain now has an account domain SID of S-10. At which point, another copy of the template VHD is made. It's renamed to Luigi, and it's joined to the Princess child domain. And the domain join operation succeeds, and everything moves forward. It's all peachy, to build upon my particular scenario. Finally, PowerPoint crashes. There we go. Child Super Mario Brothers is granted read-write access to the Game Boy share on the Luigi machine. Again, remember, Luigi was a copy of the template VHD, and I did not mention that it was sysprepped. If you think about the time span that could elapse between the creation of the template VHD, using it to build the peach.com domain, and then 2 years later, somebody going and taking the same template VHD off the shelf and then deploying it successfully without any indication of error as a domain member in the child domain, you'll see why I keep saying this scenario is not contrived. It's perfectly reasonable. You've already admitted that you use these template VHDs. The question is, do you have enough process in place? I said process, my mum would kill me. Do you have enough process in place to go ahead and make sure that you always sysprep them? Some do, some don't. So it's a domain member right now. Finally, the Peach administrator user is added as a member of the Super Mario Brothers group in the child domain. The Super Mario Brothers group was the one that was just given read-write access to the Game Boy share on Luigi. Now, finally, the stage is set and the question is posed. Peach administrator logs on to a Peach domain member. So the admin of Peach, the root domain, logs on at a Windows 7 domain member as the administrator of the domain, just as they should, because you're not supposed to log on, according to best practices, to domain controllers. Agreed? None of you do that right. You never, ever log on interactively at domain controllers. That's what I thought the response would be. Thank you, sir. I shall give you some money for that response. Perfectly viable. All right. The Peach administrator on that Windows 7 machine tries to access // or whack-whack-luigi.princess.peach.com/gameboy. What happens? Does Explorer come up and give him a view of all of the files that are inside the Game Boy share at this point? What happens? Anybody care to volunteer an answer? There's an error, yes? Let's go a tad more specific there. We get an access denied, and here's why. If you took a look at the access token that the Peach administrator has at this point, it's all hooked off of the key identity, the user. We call this the primary SID. It's not the primary SID that you know of within the directory, for those of you that know AD attributes inside and out. It's not that primary SID. It's the primary SID that's an artifact of an NT token and the curb ticket in which the NT token is housed. The primary SID is the anchor for everything. What is the SID of the administrator user? It's on the board. S20500. What is the account domain SID portion of that? S20. What is the account domain SID of the Luigi machine? S20. Of the Luigi machine, the domain member is S20. Why are the two account domain SIDs the same? Because I deployed the domain member and the domain controller that created Peach.com from the same template VHD without sysprepping them. Okay, well, that still doesn't explain why we're getting access denied. When the Luigi machine looks at the NT token being given to it, and Kerberos is the vehicle that gets it there, it does all of its decryption, takes out the NT token from the pack, and it's got all of this identity data, all of these SIDs, and it looks at the primary user SID. And the primary user SID says, I'm S20. And Luigi says, how can you, coming from somewhere else, have an identity that I own? Luigi claims ownership over the entire S20 SID space. Subsequently, when somebody that's remote to Luigi tries to present it an identity that falls within its own identity space, one that it claims 100% ownership over, what do you think Luigi considers that act as? Right, there's a security boundary being crossed. You're trying to spoof an identity, or to use the nice phrase, you're elevating your privilege. So it's an elevation of privilege attack. What do you think Luigi subsequently does? And I'm not coming up with fictitious things as to what it should do here. These are Windows behaviors that have existed for years. What do you think Luigi will do with that? It will filter the SID out. How many of you have heard of SID filtering? Okay, that's a technology that's usually associated with trust boundaries, where we filter tickets or tokens as they come in across a trust boundary. We actually got that idea from SID filtering that's been in Windows forever and a day. So Luigi takes one look at it and says, you cannot possibly give that to me because I'm the only one that can issue SIDs that fall under the space S20. Therefore, you are impersonating my users. I refuse. Luigi filters out the S20 SIDs, leaving a token with the rest of the groups that are perfectly valid. But now I've got a token that has no primary SID anchoring the thing together. What do you think Windows does with tokens that have no primary SID left? For example, imagine an auditing event. Imagine that token was used to delete 1,000 very sensitive files in your organization. Who would we say in the audit log did that if we'd filtered the SID out? We just lost the owning user because we refused to honor it. Therefore, we'd have no ability to audit anything that this identity did on that computer. Subsequently, if the primary SID is lost, the entire token is rendered invalid, resulting in access denied. By show of hands, who understands that scenario? I know it's kind of complicated. Okay, if I get 50%, I'm happy to not do it again. So that was about 75. If any of you that didn't raise your hands want to come and probe me about this one at the end, please feel free to do so. This is a realistic scenario that we now have case data for. And based upon the people in the room that raised their hands, how many of you from those that raised your hands earlier think this sounds like it could actually occur in your organization due to the potential absence of process? So that was at least 40 to 50 people raising their hand there. So be very careful with this, because diagnosing this is nightmarishly difficult. Imagine trying to figure out why they're getting access denied when every other user seems to work just fine, depending on where they come from. Very, very difficult. Is there a question there, sir? So the question there was, in the future with claims-based authentication and authorization, would this still be an issue? The theory states that it would not be. Claims are simply a means of expressing a value about myself and then signing the claim such that it comes from a trusted entity. And then the person that issues it and the person that consumes the claim both trust the same entity. So subsequently, there's no actual issuing authority beyond trusting the claim itself. So it sort of would exist, but it would actually be an intentional usage, to answer your question. It's kind of a difficult one because we don't really have claims in Windows per se beyond ADFS. So it's a bit difficult to try and envisage how that would be implemented, because at this point in time, it's purely fictitious. So in the hypothetical world, my guess is this would actually be intentional, as opposed to an elevation of privilege. All right, scenario 3, I set up a machine. We'll keep it simple again. We call it M1. Its SID is S10. We clone M1 and we get M2. Okay, because I renamed it. I did the right thing, at least to that extent. I now have two machines, both of whom's SID is S10, but at least their names and addresses are different. I then create two forests, named forest1.com and forest2.com. The account domain SID of forest1.com is obviously S-10. The account domain SID of forest2.com is also S-10. I then try and create a trust. So I think the gentleman's seen the presentation before, or has been through everything I'm articulating here. Does the trust work? By show of hands, no. I'll give you some more time. By show of hands, no. There you go. No, it does not work. We cannot possibly set up a trust relationship when the two domains have no ability to differentiate security principles from either side from one another. They all look the same. The admin user would be the same, exactly the same, because the RID is identical. It would be a complete nightmare. So we do not permit trusts to exist. We actually check that during the creation. Final scenario, scenario 4. We create a domain from machine 1, and we call it dom1.lab. We install a new machine, M2. We clone M2, and we get M3. Okay, so we had a new machine, M1. We have a second new machine, M2. We clone it, and we get M3. M1 created the domain, but it wasn't a clone. Only 2 and 3 are clones. We promote M2 as a replica in dom1.lab. We join M3 to the dom1.lab domain. Anything wrong with this scenario? So, by show of hands, yes, this is broken. No, this will work. 3, I like to stay squarely on the fence, so I'm right regardless. Okay, and the rest of you are somewhere entirely different. So, in this particular case, when we DC promoed M2 and made it a replica of DOM1 from M1, we discarded all of its identity data because it's a replica. It's not the one that's creating the domain. The identity for dom1.lab was already seeded by M1. So when M2 joined, it got told what to do. If you wish to be a domain controller in this domain, you must share the same account domain SID as I do. You must replicate all of my security principles. You must be, quite literally, another me with a different name and a different IP address, and some other replication algorithms also impose additional immutable identifiers, which we'll discuss in a second. Subsequently, M3, although it was originally a clone of M2, is no longer a clone of anything because the SID was discarded when M2 joined M1 as a replica. By show of hands, who understands that scenario? We only use the account domain SID when we seed a... Excuse me, do you have another one? Sorry. Do you have another one of the clickers? I don't think that was going to work because there appear to be about 3 of them now. Question over there. Thank you for giving me some time to allow the gentleman to repair my clicker. So the question there is, does the Active Directory restore mode still share the same SID? Off the top of my head, I think we reseed that during promotion, but I will have to check that. It's a very good question. Is Hyro in the room? Can you make a note of that question, Hyro, unless you know the answer? As we promote a DC, do we resid the local DS restore mode, Sam? We do? OK. Hyro owns the DC promo process from end to end. So he's the PM that owns that whole thing. So if the right person to have in the room doesn't know the answer, I feel OK about that one. But we will find out the answer for you. Good question. Very good question. OK, so I explained why that would work. I shall use the keyboard for a second. So the answer is no, there's absolutely nothing wrong there. So Windows concepts, then. It's working. Thank you very much. You see it needed that. It's working much better than before now. Right, so update sequence numbers. We're talking here about some of the Active Directory replication fundamentals. A USN. This is kind of like a clock on every DC. It's OK. No, I didn't really drop it that time. As you can see, I'm rather animated. It must be all the coffee. No more Starbucks. We use this on DCs as metadata that we stamp against every update to the directory. It basically tells us the serialization of updates as they're introduced into the database. Every DC has its own clock that rolls forward. It's not one USN tick for every single value. It's one USN tick for every transaction. And a transaction could encompass a larger number of values. So even if 2 replicas were, as far as you could tell, born at exactly the same time, their USNs may or may not roll at the same sequence. You with me? Because if I go telephone number, apply, then I go last name, apply, SAM account name, apply, fax number, apply, country, apply, I did 5 discrete transactions because I hit apply. When we come to replicate those, how many do you think we replicated? 5 updates in 1 transaction. Therefore, on the replica DC, how many USNs ticked? Just 1. So the USNs will always appear to be different. DCs maintain the notion of the USN state of all of their replicas. So if the gentleman in the front and I are 2 replicas in a domain, and somebody creates a user on me, and that requires that I consume 10 USNs to write all the little pieces, all the artifacts of a user. He then comes to me and says, the last time we spoke, your USN was at 1,000. My USN is now at 1,010. So I now know that I need to give him everything in my directory that has a USN stamped on it that is greater than 1,000. You with me? They're just like DNS version numbers, for those of you that understand how bind works in DNS. They're very similar to that, except they have an infinitely larger scope because they're 64 bits. Very, very large. You know, we all come up with our standard childish human denominations for what that number is, like a quadrillion or a gazillion or something along those lines. Very, very large number. So this is the means by which we determine how in sync or out of sync we are between replicas. This is totally independent from system time, so please note that at the bottom. We do leverage system time for certain things, but it's not fundamental to the Active Directory replication algorithm itself. This is a dump of the metadata of a given object. I did it in PowerShell just to be a good Microsoft citizen, but as you'll notice, I'm actually using a command line binary and not PowerShell to do it. I just hooked the object reference using PowerShell, and then I rep admined it. So this is a very well-known command for people that have worked with AD for years. It's a means by which you can look at an object from Active Directory's standpoint, not from your standpoint. This is not LDAP looking at the directory data. This is AD looking at the directory data. And it's showing you what the local USN is. It's showing you which site the DC that originated that data is in. It's showing you the name of that DC. It's showing you the USN, i.e. the clock tick value at the time that data was introduced, etc. This can be useful for diagnosing faults, but beyond that, not particularly handy. So you can see here, that's basically what it looks like under the covers inside AD. Notice we have a differentiator between originating USN and USN. This notion of originating is, again, very important to AD. The notion of originating is the DC upon which the data was born. Think about it. You've got 10 DCs. They all hold the same data. But the data had to start somewhere. The LDAP write didn't spray out to all 10. We don't replicate on the client side. We replicate at the back end. Replicating on the client side wouldn't be replication at all. It would be cheating. So we basically originate the write against one DC, and then it replicates to the 9 others. The DC that qualifies as the originator is the one that received the originating update. And that's the USN that we stamp on there. What about when we replicate it? Notice the values in red. This is what changed as replication propagated the user object from one DC to the replication partner. But the rest of the data was preserved. So the timestamps, the originating USN, the DC on which the data was originated. All of that is preserved. And obviously, the attribute values are preserved, because otherwise that would be crap. So that's a good technical term, that. That would be crap, wouldn't it? A replicated system that didn't actually replicate values, that would be crap, yes. So a high watermark vector table, this is another notion within our replication engine. Remember the little scenario I gave you a second ago between myself and the gentleman in the front row, where I knew that my USN was 1,000. I then created a user up to 1,010. He knew that my USN was 1,000. He stores knowledge of my USN as his replication partner in the high watermark vector table. How does he identify me? How would he identify me in that high watermark vector table? Is he going to use my name? Does that sound like a good idea? No. He uses something called the DC GUID. How many of you know what the DNS zone looks like, even to a basic extent, that represents an Active Directory domain? Who's ever looked at it? By show of hands. Good. Who knows about the MSDCS container, or underscore MSDCs? And you've seen those CNAME records underneath there. Large 128-bit, seemingly cryptographic numbers. They are actually the object GUID of the NTDS settings object of the DC that they represent. So if you look at the CNAME, see who it points to by name, go and find that name in the directory in Active Directory sites and services, and look at the object GUID of its NTDS settings object. Then look up on the internet how to do something called network byte ordering, or pretty byte ordering is another term by which it's known. I'm not making that up, I promise. And that shows you how to order the bytes so that the two line up. So we literally use the object GUID of the NTDS settings object to make a hard reference, and that's what's stored in the high watermark vector table. That identifier persists with the domain controller for its entire lifetime. Okay, that never changes. Never, ever changes. Never retired until you demote the DC. So that's basically what you see, except I'm simplifying the DC GUID by showing the DC name and not the GUID itself. Finally, the last assumption that's a critical one here is the database has an identity. So Active Directory expects to go, which of the following two does Active Directory expect? Does it expect to go forward in time, linearly, never jumping back and forward, blah, blah, blah? Does it expect to go forward in time? Or is Active Directory perfectly comfortable with you going forward in time and then snapshotting it and restoring it to an earlier point without telling it you did it, and then going forward on another time path and skewing off on a different leg? Which of the two is Active Directory comfortable with? The former? The latter? Good. It is absolutely the former. One of the fundamental assumptions in AD is that the clock only ever goes forward. If you use snapshot and restore technologies on a hypervisor, what have you essentially done to that assumption? Broken it. You've tossed it to the wind. Because you snapshotted AD at a point in time. It went forward. Changes were made. It pushed out those changes to other DCs. And it owns them. It's the originator of them. Somebody then decided they didn't like the way this DC was at this point, so what did they do? They used Hyper-V's natural snapshot and restore technologies, and they restored it to an earlier point in time. How does that domain controller that's now restored to an earlier point in time get brought back up to date? Anybody? How do we bring a domain controller back up to date if it's either been offline for a long time or you just restored it using this unsupported technique? Again? You could promote it. Was that demote or promote? You could demote it and then re-promote it. What about if it's already a DC and it's just been shut down? How does it get brought back up to date? Through replication. Gentleman in the front row, good answer. Replication brings it back up to date. Of the data that it doesn't have, do you really think it's going to be happily told to replicate in things that it thinks it originated? So you try and send me data, and then the originating DC on that data says it's me. I'm going to be like, that's okay. I already got that because I told you. Do you follow what I'm saying here? The DC has been put back to an earlier point in time. When changes replicate into it, it thinks so it owns those changes. It could start consuming the same USNs for different updates. The result of this is what we call a USN bubble, and the situation that created it is a USN rollback. We have some mechanisms in place to detect USN rollbacks, but they are by no means a 100% coverage implementation. We did our best to figure out how to do this, but the algorithm itself is fundamentally flawed in this manner. Now, that doesn't mean that we designed it wrongly. It means that we made an assumption about time always moving forward, and that assumption needs to be maintained by you guys when you're using hypervisor technologies or any other technology that can literally discard it. You must do the same thing. That would beg the question then, how does acceptable and supportable backup and restore work? If you restore a DC using supported processes, such as NT backup or third-party software. Not authoritative, good try though. We reset the invocation ID so that the DC no longer knows who it is. So we give it a new invocation ID. So now when it comes up, and all those changes that are out there that it previously authored, it doesn't recognize them as its own anymore. Subsequently, it has no bother about pulling them back in. So as long as you reset a DC's invocation ID down to the nanosecond of the point at which the restore brings it back to life, and I mean nanosecond, don't try doing this yourselves by hand. You cannot possibly work as fast as a computer works. You might be able to reset it at some point and get it in there nice and quick, but you're still going to end up poisoning it. So this needs to be done in a supported manner while the DC is not processing. It needs to be an offline reset so that it comes back up having changed the invocation ID. The up-to-dateness vector is the place where we store knowledge of how up-to-date we are with others, and the immutable ID that we use in here is the invocation ID. If any of you have used the command repadmin/showutdvec, you may notice that that table seems to be very, very large, disproportionately large to the number of DCs you have. Has anybody actually run that command? Show of hands, anyone? repadmin/showutdvec. Very few, I think I only saw 1 or 2 hands there. This command will basically dump the up-to-dateness vector table, but because we never retire them completely, they persist for the entire lifetime that the DCs are around. They're just not its current identity. But all domain controllers are aware of their past identities. Now, there's another scenario where we reset this invocation ID that has an impact on replication that I want you to be aware of. How many of you guys use application partitions for anything other than DNS? Oh, 1. Excellent. I'd love to hear what that is at the end of the session. If you go ahead. Do you want to pass that forward like a Mexican wave of voices, people? I can't quite hear. Exchange, okay. So they're using an application partition for exchange purposes. So if under any scenario an application partition is added to a domain controller, removed, and then added back again, what happened to that domain controller's knowledge of what it authored? It was lost, and then it was given back. What must we do with that DC to which the application partition was added, removed, and then at some later point, re-added? We must reset its invocation ID so that it does not perceive itself as the author of that data anymore. This has a replication impact because anybody that's talking to me can no longer trust their high watermark vector because my database is no longer serial. It's completely wishy-washy. Any assumption you make about the fact that we both went forward at the same progression rate is no longer valid. So if you add appNCs, remove them, and then add them back again, we reset the invocation ID. Impact, replication partners have to reset their notion of what to replicate. You may see a replication storm. Do we do a good job of dealing with this? Yes, we do. We filter out as much as we can, and most of the time it ends up being a trivial impact. But you will see it. Why am I mentioning it to you? So that you know not to do anything about it. It's just a trigger for this particular way of Active Directory dealing with its own requirements. How could this happen in reality? Add a DNS role, then you decide you don't want DNS on that box anymore, so you remove it. And then you're a good AD hygiene maintenance admin, so you remove the DNS's domain DNS zones and forest DNS zones appNC. A year later, you decide to add DNS back to that box because the same requirement has come back to light. A perfectly viable scenario by which an appNC was added, removed, and then later re-added. That will create a replication impact beyond the impact of merely adding back the two application partitions. The only reason you need to know about it is it will have an impact on slow links, and it will have an impact on your replication monitoring status. If you've got those screens out there that tell you what's going on, you will see an impact. What should you do about it? Nothing. Let it finish. That's the reason I wanted to mention it. Okay. Lingering objects, then. Who's heard of lingering objects? Oh, dear. Why, oh, why? Have so many of you heard? Who's had lingering objects? Okay. All right, so these are a painful artifact of what we just discussed. A lingering object is an object that exists on one DC, but not on another, but the two DCs think they're consistent. So they think they've synced, but they haven't. Not entirely, because one has lost knowledge of the serialized update state of the other. Give me a way in which you could introduce lingering objects based upon what we've just discussed. Use snapshot and restore on Hyper-V. Snapshot a DC that's got a replication partner, restore it. The other DC has no knowledge that you did that. Subsequently, it starts reusing the same USNs. Therefore, when the other guy goes, can you give me everything that's changed above a certain value? This guy is going to say, well, hang on, how can you be asking me for things that have changed that are a USN that's 10,000 higher than me? Do you see what would happen? Imagine the two go forward. 10,000, 20,000, 30,000, snapshot, 40,000, restore, 40,000, 30,000. He says, give me everything that's changed that's greater than 40,000. And this guy goes, huh? How can you be asking me for things that I've done that are at a value greater than I've yet gotten to? Ah, so there's some magic in there. We can use that, and we do use that. That's a perfectly viable means by which lingering objects can be introduced. So again, a lingering object is something that exists on one DC, but not on another, but the two believe themselves to have converged. There's also a very small window. Who knows what garbage collection is? Okay, so garbage collection runs at, you're talking about tombstone lifetime, I assume, yep. So basically, as you delete an object, we tombstone it, which means that we don't can it completely because we have to replicate the deletion. Then after 60 days, that's when we expunge it completely from the database. Or 180 days, depending on how your tombstone lifetime was set. But I think that's all common knowledge now, whatever that value happens to be in your AD forest. At the end of the tombstone life cycle, a process known as garbage collection, which runs every 12 hours, looks at all the tombstones and figures out which of them are too old and therefore qualify for expunging from the database. Now, imagine those 12-hour cycles are slightly off. So they're never going to be exactly at the same point, right? Because we make no effort to synchronize them. As a DC comes up, that's where its 12-hour cycle begins from. So you could have a DC that's there and a DC that's there. In 6 hours, this guy's going to run his garbage collection. In another 12, this guy will do his. So this guy went first, and he erased some stuff. And then for some reason, the other guy that hasn't yet triggered his garbage collection modifies the tombstoned object. Can anyone give me a scenario that's natural, not underhanded or deliberate, that would cause a deleted object to be written to, modified in some way? Listen very carefully to this. The very first Windows Server 2008 R2 domain controller that you introduce to your domain, if you're at 2K8 or 2K3, the very first one, with or without functional levels, with or without recycle bin, will go and tattoo is recycled equals true across every single deleted object, putting it into a state that makes it ready for the point at which you turn on recycle bin. We have to have that there for the integrity of the recycle bin, or the integrity requirements, I should say, to be met. There's a perfectly natural reason for a deleted object to be touched. So now, this guy has just canned 1,000 objects because he ran his garbage collection cycle. They were at the end of their tombstone lifetime. This guy then comes in and he receives the updates from the new R2 DC to all of the deleted objects he's got, including the 1,000 that this guy just canned. And of course, he tries to replicate them to this guy, who says, how can you replicate a single attribute of change to me when the whole object is missing? You understand the scenario? So the R2 box was introduced, it updated every deleted object. This guy's still got some. They're right at the end of their lifetime. They're about to be expunged. This guy was earlier in his cycle. He already expunged them. This guy receives the updates to them because they weren't expunged yet. They were 6 hours away from being done, or 12 hours away from being done. He then replicates them to the guy that already has expunged them. And you get lingering object events all over your event log. Should you worry about it? What's the maximum time under normal circumstances that it should take to fix? No, because the deletion timestamp on the two is the same. The maximum amount of time should be a garbage collection interval, assuming it's the same on both DCs. Within 12 hours, this guy will treat those deleted objects in the same way as this one already did and expunge them himself. Subsequently, the replication requirement to push them over there will disappear because they don't exist anymore. They've been garbage collected, they're gone. A maximum of 12 hours is all it should be, because the furthest I can be away from my garbage collection cycle relative to anyone else is 12 hours, unless you're doing something to artificially impact that. Okay, so be aware there are some graceful scenarios by which these things can be introduced. USN rollback is the scenario that I just described that introduced it, where you rolled the DC back to an earlier point in time. The term USN rollback is pretty self-explanatory. However, we have a mechanism by which we can detect this. But let's first show you how we detect it, and then I'll show you how we don't. So if you walk down this, I'm afraid I don't have a laser pointer, so I can't point at it. I could try the mouse. Yes, there we go. So if you see here, we've got a virtual DC. As updates are occurring, the USN jumps from 100 to 200 and replicates to virtual DC 2, a second one over here. And we take a file copy of the VHD. How many of you actually knew that you can copy a Hyper-V VHD while it's still running? That scares me, and now the rest of you do. Good, well done, Dean. Yes, don't do that. It's not a good idea. That is not advice. It is strange to me that we don't actually have, we as in the Royal Microsoft we and the hypervisor team, that we don't have an exclusive handle to that file, but we do not. You can actually just copy the file out of there without snapshotting or anything on a live running machine. If you do that, good luck. We know. We can tell. Just want to be clear. So it goes all the way down and it does USN updates 201 through 350. So more changes were made over this period of time, and it replicates them over to VDC2. This it replicates them over to DC1 from VDC2. VDC2 then fails. So what does the admin do? This not quite well enough educated admin that did the right thing in creating backups, but did it using unsupported techniques, puts back the copy of the VHD that was at USN 200. You with me? So this has now been put back. The DC continues on. And it gets up to USNs 201 through 300. So it's introducing new changes. This guy then says, excuse me, Mr. VDC2, could you give me any update that is greater than 350? Look at the text in the middle. So this guy has updated and improved its database only up to 300. But this DC1 makes a request of VDC2, give me all changes that are greater than 350. Why is it asking for changes that are greater than 350? Because that's how far it got, as far as it's concerned, the last time they spoke. At which point, VDC2 says, wait, that's impossible. The only thing that could have happened is a USN rollback. There's a misnomer in the industry that DC1 then refuses to replicate. That's not the case. VDC2 self-disciplines. It turns its back on everyone else and refuses to replicate because it believes itself to be flawed and potentially introducing distributed poison. So if we take that scenario and we make it a wee bit worse, exactly the same again, but down the bottom here, we managed to introduce updates 201 through 355, because the moment you restored the snapshot, the DC got really busy, and lots of people started throwing updates at it. And it pushed the USN past the point that it had already gotten to and replicated out. Now, when DC1 says, excuse me, Mr. VDC2, can you give me all of the updates that are greater than 350, what does VDC2 think? Sounds fine. Here you go. There are 5 or 6 changes for you. And everything's peachy. Do you see why I said earlier this is by no means 100% coverage? This is non-deterministic from our standpoint because we don't get to dictate when other DCs make their request for updates. It could be according to your site topology. It could be notification-driven. It totally depends on your infrastructure, and we cannot influence that. So this is a non-deterministic mechanism by which we try to prevent the introduction of lingering objects, but we cannot guarantee it. It's a best effort at best. If you get them, detecting them is nearly impossible at scale because you have to compare attribute by attribute, value by value, object by object across every NC against every other instance. Very, very difficult problem. Okay, so be aware with that. Improper backup and restores. How many of you have got backup solutions that are not Microsoft? It's what normally happens. Specific to AD, how many of you have got backup solutions for Active Directory that are not Microsoft? Okay, again, that's still about 30% of the room. How many of you validated that that is an Active Directory supported backup technique? That's about the same number, close to it, so good. Very good. This is a requirement, because if I restore, let's say that I back up Active Directory with X third-party backup software. When I restore Active Directory, what must the restored Active Directory domain controller do to make itself safe in the distributed system? Reset what? Reset, good answer, sir. Reset the invocation ID. We don't know we've been restored because you did it while the OS wasn't running, typically. So it is the responsibility of the application vendor that produces backup software that claims I am AD capable to introduce the registry tweak to the DC that is reviewed during the boot path. So as a DC comes up, we check that registry tweak, and if the registry value is there, we reset our invocation ID before the database and replication and everything else is initialized. If the application vendor is either unaware or simply failed to meet the requirements or got it wrong, then things break. The DC comes up, its invocation ID is the same as it was at the point it was backed up. However, it's now at a point earlier in time with no means for the rest of our distributed system to be made aware of that fact. USNs get reused, you end up with USN bubbles, lingering objects, and you've got a USN rollback scenario, and you may end up with that for the rest of your life. Take a look at the things, the symptoms that come out of this. This is a real case, by the way. Obviously, I'm not put the customer in there. 2,500 users not able to log on. Why? Passwords were synced over there and not over there. You see how this can happen? The DCs won't replicate stuff because they think they're already in sync. Users having access to resources that they should not have access to anymore. Non-deterministic DC identification. So we have a process in AD called the DC locator. It's going to be covered fairly extensively in Hyro's session, which is, when's your session, Hyro? Tomorrow, 5 p.m.? And it's called the Tips and Tricks of Active Directory after 10 plus. He might actually beat me on title length. It was my title anyway. I made it up, so I still win. So Tips and Tricks of Active Directory after 10 plus years, blah, 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 blah. Inside there, Hyro talks about how DC Locator works. DC Locator is a very intelligent process, but it's still designed to try and balance the load among all viable DCs. If DCs aren't replicating, then what is my authentication experience going to be if I get a different one each time? It's going to vary. My password will work there, and it won't work there. So I reset it there, and now it's different there to there. It's just going to be a very, very bad experience for your users, and your support desk will be the one that pays the price. So be very, very careful with backup and restore. You could reset this invocation ID yourself. You could do it. I would consider it the absolute last resort. This really is my directory service is on its knees. Nobody can come up with a decent way of fixing it, and I've got this DC here that might be able to help, but I don't want to introduce it because I'll just compound the existing problem and make it worse. All right, it's worth the risk. I'm going to add the registry tweak manually to that DC and boot it up and see if it can help me solve the problem. And that may well be a time where you use that authoritative restore technique where we go and stamp the metadata of all of the data on that DC and have it push it back out, claiming to be the owner of absolutely everything. That's what an authoritative restore does. No different in terms of the restoration operation. It's just touching the metadata to make it superior to everybody else's, so you take what I say as fact. Okay, what about P to V migrations? Who can tell me what a P to V is? Physical to virtual. Who has done P to Vs, whether it be on domain controllers or otherwise? Oh, that's at least 50% of you. How many of you have DCs that are virtualized? On VMware ESX server? On Citrix? Oh, you lonely, lonely individual. What about on Windows Hyper-V? Okay, so it looks like Citrix is the bottom, but it's out there. VMware is far and away the top, and Hyper-V is somewhere a little bit above Citrix. I've used all three. I happen to actually quite like all three. I still tend to... I can't go there. I work for Microsoft now. Okay, so they're all good hypervisor platforms. They all provide a P2V migration capability. If there are Hyper-V people in the room, my apologies. I didn't mean that. I'm never going to get myself out of this one. So they all provide a P2V capability. This is becoming a very, very popular means of moving physical workloads into virtual machines. It makes sense to do it because the technologies are deemed to be sufficiently reliable now. If you do this, just make sure that you've got some statement from whoever your vendor is that they are absolutely never allowing the physical and virtual equivalents to exist simultaneously, even if it's for a nanosecond per my scenario earlier. They absolutely must have a process that allows the physical machine to be completely dead at the time it is spewed into the virtual environment. This, in my opinion, shouldn't really be a real-time task. We're not doing failover in virtual machines, migrating between hypervisor instances. We're taking the physical box and converting it lock, stock, and barrel, and hopefully permanently into a virtual machine. For the most part in AD, that really shouldn't be a real-time thing. That should be you do it, and the box is dead at the time it's being done, and it's just having its disk scavenged and converted into a VHD, and hopefully some nice stuff done with driver artifacts and all the requirements that the virtualization platform brings. So just be very careful with this. Theoretically, it should work fine. It just depends on the vendor, so I can't give carte blanche, okay, yeah, this is all good. I don't know. Depends on the vendor. What about virtualizing read-only domain controllers? Can I take a snapshot of an RODC and use them? Well, you can see here, sort of mostly, but we've got Ryan in the room. Ryan does a heck of a lot of testing on AD, and he's been doing it for years. Ryan, do we test this? We do? Okay. So Ryan's saying we do test this. What would you say is your support statement or your comfort of supporting this, Ryan? Don't do it. So while we can't specifically label any symptoms based upon our tests, Ryan may have some, and I can mention those later, or you can come up and ask me, and I'll ask Ryan. There are a couple of artifacts that I've listed here, such as timestamps, that RODCs do actually permit you to write, but they don't get replicated out. Since read-only DCs don't replicate changes out, theoretically, doing this with RODCs and even rolling them back and forward in time is theoretically not a bad thing. But since we don't test it to the point of a traditional deployment mechanism or a traditional backup restore mechanism, I wouldn't suggest that you do either. Hopefully, you shouldn't find a need to do this because there's sufficient alternatives. Can you clone an RODC? For that matter, let's broaden the question. Can you clone any domain controller whatsoever? No. If you clone a DC and you reset its invocation ID and its name and its IP address, is that enough? No. There's other stuff in there that we haven't even had the time to cover here. There are numerous immutable identifiers that every DC has that are supposed to be its and its alone. Things like SIDs they share because that's all about the objects, the artifacts the service it's trying to provide. That's not about the core architecture that it builds those things upon. You cannot clone DCs. How many of you would like to be able to clone DCs? Okay, so nobody deploys DCs. Well, we've got about 10 people there. So some of you would like to clone DCs. Why would you like to clone DCs? Right. So the gentleman here is saying that we clone DCs for taking them out of production and shoving them into test. How many of you clone DCs for that purpose? Okay. How many of you would imagine that cloning a DC would be a reasonable way of doing disaster recovery? If you've only got a single instance that you deem to be good, this would be a way of scaling it back up. However, again, as much as you might want to do this, and as much as virtualization platforms make it a trivial undertaking, just copying a VHD, it isn't supported. There's no real way that you could possibly know enough about our system and get the changes in there quickly enough to not introduce artifacts of the cloning operation, so please be careful. Question at the back there, gentleman, had his hand up, I believe. Do we have a microphone there, sir?
So that's okay.
Great. So the gentleman's point was he would like to do this for disaster recovery purposes. Frankly, I agree. I think this is probably a very good reason to clone DCs, because at that stage, think about it, for those of you that have experience with AD administration, you don't know the state of your directory, but you do know that one DC represents a good enough picture of it. Now you need that to be the authority. So now you've got a DC promo, tens or potentially hundreds of DCs from that. That could be quite time-consuming and therefore leave your organization or service offline. If, however, you could clone that guy, then you've got a DR solution that is hands-off and extremely quick, at least in theory. Obviously, this isn't something that's there yet, so theory being, we can take the data that's on there, do some clever stuff with it because we know what we need to do, and bring it up as a new box. Okay. Any other questions on that? Yeah, go ahead. So basically doing a copy on write, you mean? So the gentleman here is talking about copy on write technologies with SANs, whereby you can clone a LUN on a SAN, and it doesn't actually clone anything. It just starts recording changes as they're made to the two discrete instances, and then copies the sectors or blocks as they're changed by either side of the fence. So copying a 10 terabyte disk, for all intents and purposes, is instantaneous. Imagine that from a DR standpoint. Hyro, make a mental note. That's actually quite good. I like that scenario. I'm just conceiving how quickly I could deploy hundreds of DCs using that technology if they were all housed on the SANs. I could roll DCs out very fast. Good point. Okay. So, some good points there. Thank you for the feedback. All right, miscellaneous considerations. Yay, I've got 2 minutes and 11 seconds left, and I got to the slide where we changed something. Remember I said we changed our mind. We learned something. So I'm being facetious in my little bullet point there. If you've followed our existing guidance, we've changed our minds. That's not really the case. It's not like we go, oh no, I don't like that idea anymore. Let's do it this way. We actually learned something new. We've improved the documentation already. The moment I learned of this, and Hyro is also involved in this as well because he owns, or did own, I forget which it was, TimeSync. We basically provided that feedback, got more data from the hypervisor folks, provided more feedback, went round and round and round and round and round, and eventually concluded, oops, our existing guidance probably isn't optimal. So the Windows Time Service has a very well-defined algorithm for time sync within a domain. Our suggestion now is let it fly. Let it do its thing. In the past, that guidance differed a bit. So are we suggesting that you disable the virtual machine integration components completely? Again, I want to emphasize, no, that is not what we are suggesting. Absolutely not. What we are suggesting that you do is disable the virtual machine integration component, that's the VMIC acronym you see on the board there, TimeSync provider. TimeSync has a very complicating underlying algorithm. Things vote. TimeSync providers that come from hypervisors tend to vote as real-time clocks. They go, I am absolutely correct. So now what would happen if the hypervisor's time wasn't correct or didn't participate in the Active Directory domain's time sync hierarchy? Now the clock is jumping back and forward each time it reboots. It gets the time seeded from the hypervisor during its bootstrapping, where you see the BIOS and the rest of the post coming on, the power on self-test. And then as the OS comes up and the time sync kicks in, we go and take it from AD, and it could potentially jump either skewed forward or slewed backwards. So the ideal scenario is disable the time sync provider in the guest OS, leave time sync switched on in the VM definition, and introduce the hypervisor to the time sync hierarchy that Active Directory generates. It doesn't have to be syncing from an ADDC. If you've got the PDC and the forest routes syncing from an atomic clock or out on the internet, then tell the hypervisors to go out there and get it. All you did is make the pyramid of time converge at the same root point. Even if it's not the same root point, but you trust the two time sources because they're known to be military-grade accurate, that's fine by me too, as long as you place that level of faith. The goal here isn't sync from the same source, it's converge on the same exact time at all times. Sure, we can tolerate slight jumps, but you may get some problems. It's possible I used the word wrongly, but I was referring to the same exact time source. They don't have to have the exact same time. In fact, our time sync algorithm is nowhere near what I would consider to be exact, not even close. We can tolerate up to 5 minutes with Kerberos, but even that is something that we've got flexibility on. Somewhere around Windows Vista. How many of you deployed Windows Vista? How many of you have deployed Windows 7? Yes! Somewhere around Vista, we implemented a technique by which Kerberos uses time. Do you guys all know that Kerberos uses time to determine whether authentication was successful? It's called the authenticator, an encrypted blob of time. If that's more than 5 minutes out, authentication can fail. Somewhere around Vista, we changed that such that the KDC then says, well, wait, the timestamp looked valid, so how about try it with this one? And the KDC actually sends its time back to the client in plain text, and then says, that's subtle, and then says, go ahead and re-encrypt that using the same cipher and the same key. And if that works, I'll trust you. So we don't have to be exact on our time, but we don't like the notion of time going forward and then backward and then forward and then backward. If they're slightly off and they maintain that delta, that's OK. But going forward and backward can introduce oddities in the directory database with conflict resolution, specifically a replication facet. If you'd like to come up to me afterwards, I'm conscious of time here, by all means, and I'll explain where it comes into play. So there's some security considerations. I'm going to have to jump through this, but I do appreciate the Q&A. The point that I wanted to get to was read the rest of the deck. There are some additional pieces in there that I just ran out. I'd needed about 5 minutes more, so please make sure you do that. In addition, since I always forget, please complete an evaluation. The feedback that you provide us gives us information on whether the session was shaped correctly, whether it was pitched appropriately, level-wise, the technologies were worthwhile. So please do that. Beyond that, thank you very much for your time. I shall stay around for as long as I can. Please come and keep the Q&A going. Thank you.